Let's go over a couple of practice problems for quiz 3. In problem 1, we'd like to determine the domains for these three functions, and we'll state our answers as intervals. So in terms of domain, I look for something that goes wrong in the function. And the two things that can go wrong are if you divide by 0, that's an issue, and also taking the square root of a negative number, like -1, for example. These two things will cause a function to be undefined. If you look at a, it's x to the fourth plus 5x minus 1. There's no fractions. There's no square roots. In fact, nothing can go wrong in this function. Said another way, what is the domain? It's all real numbers, everything from positive to negative infinity. You can put any number that you want in place of x and simplify it, and nothing will go wrong. Now, the same is not true for the function g of x. In fact, I see there's a divided by, and any number x that makes the denominator equal 0 is a problem. So when does the denominator x plus 3 equal 0? Well, that's when x is equal to -3. You cannot use -3 in the function g. If you put -3 here, that means you put -3 here, and -3 plus 3 is 0. This creates division by 0. This is the only number that you do not want to use. So really, it should be that I don't want to use -3. If you express this as an interval, that's everything from -infinity up to and not including -3, and then everything from -3 not including it up to infinity. If you put a union symbol between that, we can reference this as the domain of the function. This is our way of saying you can use any number that you want except -3. In part C, we have the square root of 7 minus x. Now, the issue here is if anything underneath the square root is going to be a negative number. Said another way, I want 7 minus x to either be positive or equal to 0. So to solve this inequality, I'm going to add x to both sides, and we get that 7 is greater than or equal to x. Or maybe a better way to state this is x is less than or equal to 7. As long as you choose a number that is equal to 7 or less than 7 and put it in place of this x, it will ensure that you do not have a negative number underneath the square root. The way you can write this as an interval is everything from -infinity up to and including 7. So the domain is this. It's from -infinity up to and including 7. So these are the answers for part A, B, and C. Let's find the inverse of the function f of x. The way I like to think of this is I'll replace f of x with y. They mean the same thing. And the inverse is the equation that switches the x coordinates with the y coordinates. So if we take this equation and switch y to x, and we switch x to y, well, this is in fact the inverse. Now, it's not expressed as a function. The second step is going to be to solve for y. But when you solve for y, it'll be an equation, and that equation is going to be the inverse of the function f of x. To solve for y, I can add 2 to both sides. And to solve for y, I can then divide both sides by 3. On the left, we get x plus 2 over 3 is equal to y. And this is the formula for our inverse. It is customary to replace the y with the symbol f inverse like this. And the equation is x plus 2 divided by 3. So this is the answer for question 2. Question 3 says, find the vertex, domain, and range for this quadratic equation. Now, this equation is actually written in vertex form. And what that means is you can look at this equation, and if you understand transformations, you can determine where the vertex is located. So just to expand on that a little bit, if you graph the equation y is equal to x squared, so that's this thing here, the vertex is at 0, 0. How would you go from the function, maybe I'll write the function down, y is equal to x squared, how do you transform this equation into this one? Well, it's a 3-step process. First, you would move the graph 3 places to the right. You would then expand the y values by doubling them, and then you'd move the entire graph up one place. So that's how this graph changes into this one. In fact, I'm going to list those out. It's going to first go right 3, then we're going to double the y's because we're multiplying by 2, and then we're going to go up 1. So this here, this point on the graph, which is called the vertex, it first goes right 3 places. So it goes 1, 2, 3 places to the right. So it starts here and it first moves here. The y value is 0, and if you double that y value, it stays 0. If you then move it up 1 place, it'll go up 1, which is right here. And the entire graph has to move around the vertex. So the location of the vertex is at an x-coordinate of 3 and a y-coordinate of 1. What is the domain of this function? The domain of any quadratic equation is all real numbers. So that's from minus to positive infinity. The last thing here is what is the range? And because this is a 2, the number here is a positive value that's in front of the x squared term. The graph is opening upward instead of opening downward. Because it opens upward, the y values start at 1, and they move up to positive infinity. So the range is from 1 to infinity. And that's everything for this problem.